We want to find the zeros of f of x, which is an fifth degree polynomial, meaning we are going to look for 5 zeros. We'll look at the sign changes, and there's one sign change. Therefore, there should be one positive zero. And so we're expecting to find 4 negative zeros. All right, so to start looking for the zeros, we need to find the factors of the constant term, which is 16, over the factors of 1, the leading coefficient. So factors of 16 are 1, 2, 4, 8, and 16 over factors of 1, just 1. And so we divide the top by the bottom, and we'll have 1, 2, 3, 4, 8, 16. So notice that our zeros are all integers. There are no fractions. All right, so we start looking for the zeros. We usually start with 1, but we will find out that 1 is not a 0. Now we're going to try negative 1 after that. So let's try negative 1. So we bring down 1. 1 times negative 1 is negative 1. 3 minus 1 is 2. 2 times negative 1 is negative 2. Negative 4 times negative 2 is negative 6. Negative 6 times negative 1 is positive 6. Negative 2 plus 6 is 4. 4 times negative 1 is negative 4. Negative 12 minus 4 is negative 16. Negative 16 times negative 1 is positive 16. And we'll have here 0. All right, so the next thing to do is find if negative 1 is a 0 again, to see if it's a double 0 or a triple 0. But we will find out that it's not a double 0, so we are going to try another one. We're going to try the next number, which is 2. So let's try 2. So we bring down 1. 1 times 2 is 2. 2 plus 2 is 4. 4 times 2 is 8. Negative 6 plus 8 is 2. 2 times 2 is 4. 4 plus 4 is 8. 8 times 2 is 16. And we got our second 0. So we have 2 zeros already. And we found our positive 0. So, okay, so we're expecting to find the rest as negative zeros. All right, so the next thing to do is to test if 2 is a double 0. It might be a double 0, but we will find out that it's not. And then we test if negative 2 is a 0, and we will find out that it's not a 0. And then we go on to 4. See if 4 is a 0. If it doesn't work, we'll try negative 4. So we'll try negative 4 because 4 is not going to work. So we bring down 1. 1 times negative 4 is negative 4. This becomes 0. Okay, we got a 0 here, but we need to continue. The 0 that we're looking for is at the end. So 0 times negative 4 is 0. 2 plus 0 is 2. 2 times negative 4 is negative 8. And we get a 0 here. So we have our third 0. So far we have 2 negatives and 1 positive. So this is now our quadratic factor. Since we're looking for 5 zeros, we already found 3. So we're down to the last 2 zeros. This is our quadratic factor for f of x. So we can write this as x squared plus 0x, which I'm not going to write anymore, plus 2 equals 0. To solve this, you can use quadratic formula, or we can simply isolate the x squared and undo the operation, just like what we did before. So let me bring it over here. So x squared plus 2 is equal to 0. I'm not going to use the quadratic formula. Instead, I'm going to solve the equation by isolating x squared. So we take away 2 from both sides, and we get x squared equals negative 2. So now we need to undo the squaring by finding the square root of both sides. Whatever you do to the left, you do to the right. So now we'll have x is equal to, we'll have positive, negative. Now we have a bit of a problem here because I cannot find, we will not be able to find a number that when you square gives you -2. Because when we square a number, we either get a positive number or 0. So we'll never get a negative perfect square or a negative square of a number. So this is not the same as square root of 2. However, mathematicians notice that these, whenever the zero of a function turns out to be something like this, that this is not visible in the graph. If we graph this, we will only see these 3 zeros and not these ones. So mathematicians call them imaginary numbers. They label them imaginary because it's not visible in the xy plane. Now, this is the same as square root of -2 is the same as square root of -1 times square root of 2. Now, we can get the square root of 2. We can visualize this. But the square root of -1, no. So we assign this letter, which is I, for imaginary. So this is one imaginary unit times square root of 2. And so this becomes now I square root of 2. So it indicates that this is an imaginary number. Because this is not imaginary, or rather this is imaginary, this is not real. It's not visible in the graph, so not real. Okay, so we found our 5 zeros. 1, 2, 3, 4, 5. Again, these are conjugates of each other. So let's put them first in the diagram. -1 is an integer, so we'll put it here. 2 is an integer, and -4 is an integer. So these are the rational zeros of f of x. Did we find any irrational zero? No, there is none. Okay, so we don't have anything to put there. And then imaginary zeros. These are the imaginary zeros, and we have I square root of 2 and its conjugate -I square root of 2. So again, these come in pairs. There's like 2. We cannot have a polynomial with only one imaginary zero. It has to come in pairs because when we square root here, we get 2 answers, positive and negative. So there's our 5 zeros, 1, 2, 3 real zeros and 2 imaginary zeros. Now, if we look at the signs now, we are expected to find 1 positive zero, and we have 1 positive zero. We expected to find 4 negative zeros. However, we only have 2 negative zeros. Why is that? Because there are 2 zeros that are imaginary and that we cannot classify whether they're positive real number or negative real number. So instead of 4 negative zeros, we end up with only 2 negative zeros, reduced by the number of imaginary numbers that we have here.